So the assignment which is related to Newton's law of motion, we did the first two questions from this assignment. We'll start with the third question, which is on page number 4. In this question, during a lesson, Newton's law of motion, student says, we do not really need to bother with Newton's first law because it is included in the second law. So this is a statement of the student. Student said that we don't have to bother about the Newton first law. It is all included in the second law. State Newton's first two laws of the motion and explain how the second law includes the first law. So you just have to show a relation between the first and the second law, and you have to state the Newton's law of the motion. So what are the Newton's law of a motion? According to Newton's first law, an object. What is the Newton's first law of the motion? The Newton's first law of motion is object at rest. It will remain at rest, or object moving with a constant speed. It will continue to move when the forces are balanced or the resultant force is zero. So when the forces are balanced or the resultant force is zero, the object, if it is a stationary object, it will remain at rest. If it's a moving object, it will continue to move with a constant speed. That's the Newton's first law. What about the Newton's second law? An object accelerate or change the state if the resultant force act on the object or the forces are not balanced. So we have the Newton, this is the first statement, is the Newton's first law. How Newton's first law and second law are related to each other. So in the first law, the resultant force is zero. In the second law, there should be a resultant force, like resultant force is not zero. So how we can relate the two laws? If there is no resultant force, the object will remain at rest, or if it's a moving object, it will continue to move with a constant speed. But if there is a resultant force, or the resultant force is not zero, or the forces are not balanced, in that case, the object will accelerate. Is it clear, the two laws of the motion? And how we relate them, like, then you have to say how the second law includes the first law, because the second and the first law, what is common for the first and the second law? The common term is the resultant force. So resultant force is common for both laws. According to first law, the resultant force is zero. According to second law, the resultant force is not zero. So resultant force is a common term which is used for both first and the second law. So how you score 5 marks, 2 marks are for the statement of the first law, 2 marks are the statement for the second law. And one more thing, that the mass should be constant. You have to include that in the second law. For a constant mass, the acceleration of an object is directly proportional to the resultant force. Is it clear? Discussion? Anyone having a doubt in this part? Yes, we have to mention which one is the first law and which one is the second law. We have to mention that as well. Is it clear about the relation between the first and the second law, the statements? So how you gain the 5 marks? First 2 marks are for the first law. This the first mark, like 2 marks are there for the first law, 2 marks are there for the second law. And the third mark, like the 2 marks for first law, 2 marks for second law, and the 1 mark is for relating them together. How we relate them together? We relate them together by a resultant force. So you will mention in the first law, no resultant force. And in the second law, resultant force act on the object. That's how we go get the 5th mark. So first 2 marks for the first law of motion. Remaining 2 marks for the second law of the motion, and the last mark is for relating the resultant force with the first law and the second law. So according to first law, there should be no resultant force, and according to second law, there should be a resultant force. They don't, both are not having the resultant force. According to first law, the resultant force is 0. According to second law, there must be a resultant force. Is it clear now? Okay. Now, in this question, which is also related to the Newton's law of the motion, Einstein imagined a person in a large box without a window, without windows. He suggested that with no way to see outside, the person could not tell whether they were experiencing a gravity or in a deep space far from any effect of the gravity, but being accelerated at a 9.8. So, according to Einstein, what he suggested that if a person is there inside a box and he is not able to see anything outside, so he cannot tell whether he's experiencing a gravity or he's experiencing the resultant force, or he's not experiencing any gravity. He cannot tell that. So two scenarios we have. One is the stationary on the earth, another one is accelerating in a deep space. Accounts for the Einstein suggestion by explaining each case what a person standing in the box would feel through their feet. It may help you assume that the person has a mass m. First thing, the person who's there stationary on the ground, what is the resultant force on this person? A person stationary on the earth, what should be the resultant force?
0.
Resultant force should be 0. Forces will be there, but the resultant force is 0. So, and what are the forces acting on him? One is the downward force. Because of its weight, there will be a downward force. And the other one will be the normal contact force, which is R. So, the forces will be balanced because the downward force is there. The downward force because of the weight, the gravitational pull, and the normal contact force. So what we can say the downward force minus the normal contact force will be equals to 0, because this object does not experience any resultant force. But what about the person who's accelerating and his acceleration is same as the gravity? Is there a resultant force on this person? Is there a resultant force acting on this person who's accelerating? Yes, there is a resultant force, and the acceleration of the person should be same as the acceleration of the box. The acceleration of the person should also be 9.81, because when we are inside a container, as I give you an example, that we should have the same acceleration to remain in our place. So the resultant force on this object is not 0. There must be some resultant force. So there will be a downward force which is acting, which is, you can say it's due to the weight, and there will be a normal contact force is there, R will be there. So what I can say in this case, I can say because it is accelerating through the normal contact force minus the weight, the gravitational pull should be equals to ma. Is it clear, this case? So whenever object is accelerating, the acceleration of a person should have, like object should have a resultant force. So resultant force should always be equals to ma. So in this case, R minus W is equals to ma. Now, no, it's of 6 marks. The points which you have to include, the first is like relating the equations. The first point is we relate the equation that the resultant force, like the first person who's stationary. So, and you have to use the Newton's law as a concept, like the first person who's stationary. So there should be no resultant force according to Newton's first law. So if it is at rest, it should remain at rest as the resultant force is zero. So the normal contact force minus the downward force should be equals to zero. But for the second person, he's accelerating and his acceleration will be proportional to the resultant force. And in that case, the resultant force will be equals to ma. Is it clear? So you have 3 marks for the first box, which you have to use the Newton's first law. And 3 marks for using the Newton's second law. 1 mark is for writing the statement of the Newton's first law. 1 mark is for writing the statement for the Newton's second law. 1 mark for mentioning that there is no resultant force here. 1 mark for mentioning there must be a resultant force. And then the last mark is for relating that the downward force must be equals to normal contact force. Here the resultant, the normal contact force minus the downward force or the weight must be equals to ma. Is it clear? Discussion? Anyone having a doubt or a question till this point? So whenever you're, and the Newton third law is also there because the action and reaction forces are equal and opposite in direction. So if there is a downward force, there must be an upward force. And in this case, for this object who's accelerating in a deep space, so what we can say, whenever we use the term deep space, it means the gravitational force is negligible. Means the value of the gravity you can consider as zero. Because it's too far from experiencing any gravity, we call that as a deep space. So if the gravitational force is zero, so the weight will be zero. So if the weight is zero, we can say the normal contact force will be equals to ma. That's it. Because it's in a deep space where the gravity is zero. So if the gravity is zero, weight will be negligible or weight will be zero. So R will be equals to ma. Is it clear discussion? How we relate the motion? Anyone having a doubt or a question till this point? Look, two things are there. I'll repeat. For this one, the weight of a person is acting downward or downward force is there. So there will be a normal contact force. Okay. Because of that, normal contact force and the resultant force is 0. So R minus W is equals to 0 or R is equals to W. This object will feel the weight. This object will, because there's a downward force and that downward force created a normal contact force. So this person will feel the weight, like some force is acting on him. But what about the other person who's in the box which is accelerating and acceleration is due to gravity? So means for this person, there is no force of the gravitational force is not there. There is another force which is accelerating. So example, if I call this force as F, so in that case, F is equals to ma. So for this person, he will not feel his weight because he is in a place where the gravity is 0. So the forces, this is a force which is accelerating. This can be any external force is there. It is not listed in, like the box is accelerating with the force F. That is, they mention here, because it is having an acceleration. So whenever object is having an acceleration, there must be a resultant force act on the object. But in this case, because he's in a deep space where the gravity is 0, so if the gravity is 0, he won't experience any gravitational pull. He will only feel the force which is driving him. So the driving force for him will be equals to ma. And he won't experience any downward force or he won't feel any weight. So the person in a deep space, he will not feel his weight, but the person on the earth, he will feel the weight, the gravitational force. Now, in the example, when I wrote, I use an example that, for example, if there was a weight, there is a normal contact force, okay? But for this person, there will be no normal contact force. The normal contact force will be 0. Why the normal contact force is 0? Because the weight is mass into gravity. If the gravity is 0, then weight will be 0. If the weight, there's no downward force, how there will be a reaction force? That's why when I first explained the idea, I explained the idea, what if he was only accelerating? But now what is happening, because in the question, he's in a deep space. So if he's in a deep space, his weight is 0. So if weight is 0, the normal contact force will also be 0. So means there must be another force which is moving him and causing the acceleration of 9.8. And that force is a resultant force which is equals to ma. But he won't feel his weight because in a deep space where the gravitational force is 0. So person who's stationary on the earth, he can say, I can feel my weight. But the person who's accelerating in a deep space and he's having acceleration of a 9.8, what will be his weight? His weight will be 0. So he won't feel the gravitational attraction or he won't feel anything on his, because the gravitational pull. Is it clear? Is it clear to everyone? So what if it was only a person was accelerating? If the person was only accelerating, he will have the weight, he will have a normal contact force. So in this case, R minus W is equals to ma. And for the person who's stationary on the earth, it will be R minus W is equals to 0. But in a deep space, the weight is 0. If the weight is 0, the normal contact force will also be 0. So means this will not be there. But there must be another force, because according to Newton's second law, there must be a force which is causing an acceleration. So that's why I said weight is 0. So means R is equals to ma. When I was saying R is equals to ma, I was considering that this R is same as the resultant force, not the reaction force in a deep space. According to Newton's law of motion, action and reaction forces are equal and opposite in direction. And this is a very common question usually student asks, like we can derive a mechanism in which we use the two magnets and the car will automatically move. So in the question, opposite poles of the magnet attract one another. Use this principle, a student tried to design a toy car that could be self-propelled, like it can be moved by itself using the magnetic force. His design is shown, as you can see his design. A magnet A is attached to a body of a toy car and a magnet B suspended from a driver hands by a rigid rod. The magnet A is identical to magnet B. Students stated that as long as opposite poles of the magnets are facing one another, the attractive force created should cause the toy car to move forward. That is the student suggestion. Explain why in practice this could never work. Look, why this could never work. See, according to Newton's third law, action and reaction forces are equal but opposite in directions. So if the magnet B experience a force of 10 Newton, magnet A will also experience a force of 10 Newton. But if you see, the magnet B is connected to the person who's sitting in the car. So it means if the force on the magnet B is 10 Newton, how much force will be there on the person? He will also experience a force of 10 Newton. So if you compare only the toy car, so as you can see, what is the resultant force on this toy car? What is the resultant force on the toy car? Yes, Ahmad, that's good. The both forces are acting on the same. Is it 10 or 0? The resultant force on the toy car is 0 actually. How the resultant force? Because the magnet B is not connected to any other object. The magnet B person is holding a magnet B and a person, the magnet, like it's a toy car. So as you can see, this is part of the car. A person sitting in the car is part of the car. So if he experiences a backward force of 10 Newton and there's a forward force of 10 Newton from the magnet, what is the resultant force? The resultant force is 0. And if the resultant force is 0, according to Newton's first law, when the resultant force is 0, the object cannot change the state. If it is a stationary object, it will remain at rest. So this will work. This principle will work if the student design, if the design of the student was like this. So if student design a mechanism like this, now what will happen? This magnet example experience a force of 10 Newton. This also experience a force of 10 Newton. So this 10 Newton is a total force which is acting on this object. Because now there is a resultant force. Here the resultant force is not 0. So this car will accelerate forward. But according to student design, the magnet A and magnet B are connected to the same body. Because the magnet A is connected to the toy car. Magnet B is also connected to the toy car because they have a contact. So means it's also connected. So if the force of 10 Newton on one magnet, the force of 10 Newton on the other. So this 10 Newton is actually a force here as well. So 10 Newton forward, 10 Newton backward. What is the resultant force? The resultant force will be 0 and the car will not accelerate. Is it clear? Any doubt in this about the application of the Newton's law and the motion? Why can't they be added up? Because it is acting in opposite direction. One of the student asked a question, why we cannot add a force? Look, the force of 10 Newton forward and this same 10 Newton is on the whole object. Like I'm not saying this 10 Newton here and 10 Newton here. No, what I'm saying, this is a 10 Newton. So this is the same force which is experienced by this person because this is like a one body. If you compare, this is a one body. So if the 10 Newton forward and the 10 Newton backward, So what is the resultant force here? Zero. If the resultant force is zero, the object will never accelerate. So the same 10 Newton on a magnet B is the same force which is 10 Newton on the person. So why in practice this could never work? So the points we will mention, why in practice this will never work, because according to Newton's third law, action and reaction forces are equal but opposite in directions. But the second point you will mention, like force on magnet A will be same as force on magnet B, but both forces are acting on the same object. So the resultant force on the car, the toy car, is zero. That's why it will remain at rest. Clear about this? Another question related to the Newton's law of motion. A lorry or a truck gradually accelerates from rest, and there's a box of the mass 200 kilogram on the back. The box is not tied to the lorry. The lorry accelerates from the rest to a speed of 15 meters per second over a distance of 39 meters. Show that the acceleration of a lorry is about 3. So how we can say the acceleration of a lorry is about 3? We have the starting speed 0, we have this final speed 15, and we have the distance. So we can use the equation of the motion, which is 2as equals v square minus u square. So if we need the acceleration, it will be v square minus u square divided by 2s. So the final speed is 15 square. The initial speed is 0 square divided by 39 times 2. So what's the answer for the acceleration? We have to show it's about 3. So we will get the answer in this range, 2.88. So the 2.88 meters per second square. That's the acceleration. If I say the acceleration of the lorry or the truck is 2.88 meters per second square, what is the acceleration of the box? What should be the acceleration of the box? Acceleration of the box for a person who's looking at the box and the lorry from outside, it should be 2.88. Otherwise, if the acceleration of the box was not 2.88, it will fall off from the lorry. And if it was having a higher acceleration, then the box should move forward. So person who's observing, yeah, this depends on the frame of the reference. So because the whole picture is given to you, so it means you're looking from outside. That's why you will say the acceleration should be same as the lorry. The maximum frictional force between the lorry and the box is 630 newtons. Explain why this limits the maximum acceleration that the lorry can have without the box falling. Your answer should include a calculation. Now, for a person who's looking from here, the box is stationary. If you don't see anything from outside, the box is stationary. So, as the box is stationary, there is a forward force. The acceleration of the lorry is 2.88. So, for a person who's looking from the outside, the acceleration of the lorry and the acceleration of the box should be same as 2.88. But if their acceleration is not same, what will happen? The box will follow. Now, if the box is like if the lorry is accelerating, what should be the direction of the frictional force? Like what this box will try to do? The box will stationary. The box is stationary on the lorry. So according to the law of inertia, it will try to resist the change in state. So what should be the direction of the friction? What should be the direction of the friction? Forward or backward? The direction of the frictional force. Is it forward or backward? So the direction of the friction always try to oppose on the tires, just forward on the tires, but I'm talking about for the box, because the box is stationary here with respect to a person who's on the top beside the box, so it is stationary. So what this trying to do, it will try to oppose the change. So how it can try to oppose the change? So what it should be the direction of the friction? The direction of the friction should be, because if a car is accelerating forward, what will happen to you? You lean backward. So what should be the direction of the friction? The direction of the friction is also forward. Most of the students mention it's backward, but actually it is forward. You know why it is forward? See, if example, you're standing on the box and the truck suddenly accelerate, what will happen to you? Which direction you tend to move? Which direction you tend to move? Because of your inertia, you tend to move backward. So if you tend to move backward, the friction always opposes the change. So the friction is acting forward. Clear? So in this case, what is the direction of the friction? The direction of the friction is forward. So means that the lorry was having an acceleration of 3.88. The box should also have an acceleration of 3.88. Okay. Okay, I'll repeat. See, the lorry is moving forward. Because of inertia, we always try to resist the change. Inertia means property of an object to resist the change in state. So if the truck is moving forward, what this object will try to do? It will try to stop, try to resist the change. So when the box will try to resist the change, the box tend to move backward, tend to move backward. So what will happen to the friction? Friction always opposes the motion. So if the box is trying to move backward, what will the direction of the friction? The direction of the friction will be forward. Is it clear? So the direction of the friction is always try to oppose the motion. And here the frictional force is the only force. So the frictional force is equals to MA. So in the question, the maximum friction force can be 630. So if the maximum frictional force can be 630, because there is a limit to which the friction can oppose the motion. The mass of the box is given in the question, that is 200. It was given here, 200. So if we divide 630 divided by 200, what could be the maximum acceleration of? So what could be the maximum acceleration of the box? The maximum acceleration of the box could be 3.15 meter per second square. Means right now the acceleration of the truck is 2.88. The acceleration of the box is also 2.88. When the acceleration of the the lorry increases, like it becomes 3.15, the acceleration can be 3.15 because that's a maximum. But what if the acceleration becomes 4? The box cannot have the friction force which can produce an acceleration of a 4. So as a result, what will happen? The friction is not sufficient to stop the box, so the box will slide off from the lorry. So the maximum acceleration which this box can have because of the frictional force, it can be 3.15 meter per second square. If the acceleration of the truck is more than 3.15, what will happen? The friction force cannot increase more than that value, 630. So as a result, this box will fall off. Why can't the friction increase? There is always a limit because friction depends on the types of the surface and the surface area in contact. So there's always a limit. Friction cannot be infinity. That's why, like example, when you walk on the ground or the marble, which is highly polished, you tend to slip because your friction force cannot be sufficient to balance your force. That's why you slip. Same thing in this case, what happened? In the question, the friction can maximum be 630. It cannot be more than that because it depends on the types of the surface and the area in contact. So if the acceleration of so with this one, acceleration can be 3.15. But what if the truck was having acceleration of 4? The box cannot have acceleration 4. So as a result, it can only have 3.15. So the friction force is not sufficient to stop this box from sliding. So this box will slide off from the truck. That's why the trucks, when they're carrying a load, you will find on the highway, there is always a limit for these trucks, 80 and 100. Why the truck cannot, carrying a load can travel at 150? Because what will happen if it is having a high speed or a greater acceleration, the load which it is carrying may slide off from it. That's why there are limits are calculated for the load as well. What is the maximum load this truck can carry and what is the maximum speed it can travel with that load? Is it clear, this one? Any doubt in this? Yes, basically the friction is stopping the box from falling. So truck is accelerating. The truck is accelerating because of the force of the engine. The box is accelerating because of the frictional force. Friction force is a resultant force here. But if the friction is not sufficient to produce the same acceleration as a truck, the box will fall off. For a design feature, yes, they do cover up. Like there are always supports are there at the back. So in case if it exceed, this can stop the box from falling. That's a design feature of the truck. But in this example, I gave an example like what will happen if it is having a higher acceleration, that the box will fall off. Is it clear? This one? The next part B, about a minute left. So I'll share another link and we'll continue this. Newton's law.